Alrighty, let's look at these and figure these out, Mrs. Key. Holy moly, look at that. Alright. Graph the following, identify all the stuffs. I'm going to start with the denominator. So I've got 2x squared minus x minus 21. So I need things that multiply to negative 42 and add to negative 1. Oh, that's 6 and 7, right? So 2x squared minus 7x plus 6x minus 21. I can only take out an x, 2x minus 7, and I'm going to hope I hit a 2x minus 7. And if I put a 3 there, it works. So I'll have x plus 3, 2x minus 7. Sweet. Now let's look at the top. First thing I'm going to do on top, because I see a whole bunch of stuff there that looks a little scary, but first thing I'm going to do, I'm going to take a 3 out. That gives me x cubed plus 5x squared minus 9x minus 135 divided by 45. Ooh. I want to try factoring. Let's go for it. So I can take an x squared out of that. I get x plus 5. I wrote that wrong. That's x cubed, sorry. And then I want an x plus 5. Let's see if it works. If I put a negative 9 there, that'll be negative 9x minus 45, so that does indeedly doodly work. So you have x squared minus 9, x plus 5. That I can factor. If you need to do the work for it, it's x squared plus 0x minus 9. That's going to be x squared plus 3x minus 9. You're going to wind up with x plus 3x minus 3. So on top, I'm going to have 3, x plus 3, x minus 3, and x plus 5. Notice how I have a common factor right there and right there. That means I can cross those out and I have a whole. At negative 3, I'll figure out the y value. So the function I'm looking at right now, let me write it down so we can see it, is 2x minus 7 with 3x minus 3 and x plus 5 on top. I'm going to have a vertical asymptote when that denominator is 0. I'm going to have x-intercepts when the top is 0, so 3, 0, and negative 5, 0. I'm going to have a y-intercept when x is 0. And when x is 0, I get negative 9, negative 45 on top over 7, so 45 sevenths. That's a weird number. The whole, if I plug in, I'm going to have, plugging in negative 3, right? So I'm going to have 3 times negative 3 minus 3 is negative 6. Negative 3 plus 5 is 2. 2 times negative 3 is negative 6, so negative 13. 3 times 6 is 18. Times 2 is 36 over 13. That's a weird number. I got rid of the negatives because there were 2 negatives. And then sketch a graph. So I'm going to have a vertical asymptote at 7 halves. X equals 7 halves. I'm going to have an x-intercept, so 7 halves is 3.5. X-intercept there and at, so that's at 3, and at negative 5. I'm going to have a y-intercept at 0, like 7-ish. And so that's 45 sevenths. See how the top is bigger than the bottom? It means I'm going to have an oblique asymptote. So let's figure that out. So I have 3x cubed, 15x squared, 27, 135. I'm going to divide that by 2x squared minus x minus 21. 2x squared minus x minus 21. So I multiply that by 3/2 x. That's a weird one. So that's going to be 3x cubed minus 3/2 x squared minus 42 and 21 more is 66. Yeah, no, 63. 63, silly goose. 63/2 x. Subtract down 15x squared minus negative 3/2, so that's 30/2 plus 3/2, so that's 33/2 x squared. And then 54, 63, 9, and minus 135. Now I just got to figure out 2x squared times what is that? So 2x squared times what is 33/2 x squared. These are some funky numbers. And x squareds go away, so that's going to be 33/4. So that's going to be, get out of here, that's your oblique asymptote. And 33/4 is bigger than 8, so that means that's going to be like out here. That sort of thing. So what this curve's going to look like, pretend I went through that dot, and then there's a swoopy up here. Now, that is a lot for one question. On your quiz itself, it won't be that scary, but this covers a lot of the stuff that's going to be on your quiz. So make sure you know how to find your x-intercepts, your y-intercept, your vertical asymptotes, any holes, your horizontal asymptotes if they exist, or oblique asymptotes, which is what I had to do over here with my division. But that is a lot. Don't be scared. Okay. Next one. You should factor the top and bottom. I'm going to do that quickly, but if you need to write it out, write it out. So I can reduce away that, so that creates a hole. So there's a hole at -4, and let's plug that in. -4 minus 5 is -9. -4, it's not letting me write a 9, let's try again. -9 over 1, so that's just -9. You're going to have a vertical asymptote where the denominator is 0, that's -5. You're going to have a horizontal asymptote of y equals 1, which you could just do long division to figure out if you'd like. And you're going to have an x-intercept of 5, 0, and a y-intercept of 0, -1. If you're like, where to get -1? Plug in 0 on the top, you get -5. Plug in 0 on the bottom, you get 5. So vertical asymptote at -5. Horizontal asymptote at 1. Y-intercept at 0, -1. X-intercept at 5, 0. It's going to look like that and that. And that should cover it. Solve the triangles below. Okay, let's see. Solving the triangles means find all the pieces. So I have 2 of the sides, so I'm just going to use the Pythagorean theorem to find the third side. So I'm going to do 7, I'll write it down. 7 squared plus 8 squared is BA squared. 7 squared is 49, 8 squared is 64, so that gives you 113. That is not a perfect square, so I'll just leave it. So that's the square root of 113. Let's find angle B. I'm going to say the tangent to B is opposite over adjacent, 8 over 7. So to figure out what B is, I got to do the inverse tangent of 8 over 7. and I get 48.8. And then I'm going to do the same thing for A. Tangent of A is 7 over 8. So I'm going to do the inverse tangent of both sides, also known as the arctangent. And I get 41.2, which is good because those will add to 90, which is what I have left. So I solved that triangle. What do I have here? Oh, I have an angle and a side. So I can find that other angle. If I just do 180 minus 90 minus 49.5, I get 40.5. Let's find AB first. I don't know why. I'm going to try this angle. And I'm going to do that side. That's the adjacent and the hypotenuse. So that's cosine. 49.5 is 10 over AB. Multiply by AB. Divide by the cosine of 49.5. And type it in. 10 divided by the cosine of 49.5. And you get 15.4. Let's do a similar idea to find AC. I'm again going to use the adjacent, but I'm going to use the opposite this time. So that's the tangent of 49.5 is the opposite, which is AC, over the adjacent, which is 10. Multiply both sides by 10. You got 10 tangent of 49.5. That's going to be AC. 10 times the tangent of 49.5 is 11.7. So AC is 11.7. Jimmy is hiding up in a tree. Andre sees him. Andre knows if he stands 50 feet from the tree, angle of elevation is 20 degrees. So we have a tree. If Andre is 50 feet away, the angle of elevation is 20. How far away from the base of the tree must Andre position a 24-foot ladder? I don't know, so I got a 24-foot ladder in order to have the top reach Jimmy. So if I figure out how high the tree is, that would be helpful information. So I'm going to do the outside triangle first. So I'm going to say the tangent of 20 is the height of the tree over 50. Multiply both sides by 50. 50 times the tangent of 20. The height is 18.2. Now do the inside triangle. The inside triangle is just asking me, this is 18.2, how far this must be. So can I just do the Pythagorean theorem? So that's going to be my unknown, I'll call it x, plus 18.2 squared equals 24 squared. So do 24 squared and then subtract 18.2 squared and take the square root of that and you get 15.66-ish. So your answer, you should write out, is that Andre should put the ladder 15.6 feet away from the tree, the base of the ladder, sorry. This one, I see an angle, a side, and an angle. So that is suggesting law of sines. I'm going to do my unknown over the sine of 30 equals my known side over, I don't know this angle, but I can do 180 minus 61 minus 30 and get 89 over the sine of 89. Multiply both sides by the sine of 30, and I'm going to have 32 sine 30 over the sine of 89. 32 sine 30 over the sine of 89, and that's 16. Side angle side applies law of cosines. So that's going to be AB squared equals 25 squared, 29 squared, minus 2 times 25 times 29 cosine of 130. So 25 squared, 29 squared, 2 times 25 times 29 cosine of 130. I got roughly 2400. Take the square root of that, and I get, I'm going to call it 49. And I did it.